Alright, welcome to the Unit 8 review. This is the last unit of Term 2, so congratulations. We talked a lot about systems of equations in this last unit. So what I want to start off doing is solving by graphing. And in an effort to not take all the easy problems, I'll go ahead and look at number 3. Give you an example of what you should be looking for. So we're just going to be graphing these. So I'm going to start off with the first equation starting at 4. We'll go down 2 over 3. Okay, I'm just going to go ahead and graph that line right now. And so when I graph that, you get a line that looks about like that. Okay, and now I want to look at the other one. So the other one starts at -4, goes up 2 and over 1. Okay, I'm going to go ahead and graph that line as well. And if you remember, the solution to a system of equations is where the two lines intersect. Okay, really graphing just kind of gives you an estimated guess, or a pretty good guess usually. In this case, we can pretty much solidly say that these two lines intersect at 3, 2. And that's my answer. Okay, let's go ahead and look at the next section. We'll look at number 6 here. We're going to be using substitution. So remember, with substitution is we really want to solve one equation for one variable, and it doesn't really matter, but I always like equations that have at least one variable with no coefficient. So I'm going to solve this one for y by subtracting 4x from both sides. Alright, that's an x. So we get y equals 10 minus 4x. So I'm going to go ahead and plug this part in. Okay, 10 minus 4x in for y in that equation. Okay, so now we have 2x plus 5 times 10 minus 4x equals 14. Distribute. Just like solving equations, I only have one variable in this problem now. So 2x plus 50 minus 40x, that's a lot of x's, but it'll work out. When I simplify this, I'm going to have negative 38x plus 50 equals 14. Now, if I do things right, I'm going to be, oh, wait a minute. Sorry, that's not 40x. Wow. Hopefully somebody caught me on that one. That's 20x, making that negative 18. Hopefully somebody's paying a little more attention than me, getting to work on these videos. So we're going to be left with negative 18x equals negative 36. Divide by negative 18. And 36 divided by 18 is going to be a whopping 2. Okay, so we get 2 there. Oh, you can't see that. So x is 2. Now I'm going to plug that 2 back in for x in this one. So y equals 10 minus 4 times 2. That's like 10 minus 8. So y equals 2. So our answer, 2, 2. Okay, good job. Let's go ahead and turn the page. Hopefully somebody caught that mistake before I did. All right, let's go ahead and look at elimination now. So in this section, we're just trying to line up variables to cancel them out. I'm going to go ahead and look at number 11. And you can kind of take your pick on which one you want to do. You can either eliminate x's or y's. I'm going to go ahead and try to eliminate y's. I'm going to do that by multiplying this top equation by, oh yeah, nothing. How about we multiply the bottom equation by 3 to make that a positive 9 on top and a negative 9 on the bottom. So let's multiply that by 3. I have negative 3x plus 9y equals 0. So multiplying by 3, that's going to be a negative 18x, negative 9y. That's what I wanted. I wanted those to be opposites. And now I just need 21 times 3. And so that's going to be 63. Okay, so we get negative 21x, y's cancel, equals 63. And when we divide that, So we're dividing by negative 21, and x will be negative 3. Now that I know what x is, I'm going to plug that into one of the equations and find out what y is. I'm going to go ahead and pick that top equation. So let's go negative 3 times negative 3 plus 9y equals 0. Negative 3 times negative 3 is 9, plus 9y equals 0. Subtract 9. This stuff should become second nature at some point, hopefully sometime soon, this solving equations, because you're going to have to be doing a lot of it. So that tells me that y equals negative 1. So x is negative 3, y is negative 1. Remember to put your answers to systems of equations problems in an ordered pair. Okay? Excuse me. The next section, you're really just doing the same thing, but you're going to get no solution, infinitely many solutions. You may get an actual answer, but your odds are a little bit more likely in these 4 problems to get a special case system. I'm going to leave that one to you. If you need to remember what that looks like, go ahead and check one of the videos beforehand, and then get to work on that. Go ahead and turn the page. So here we have some application problems. Now these are real good application problems. I've actually used some of these as work sample problems before, okay, and that should tell you something, that your next work sample coming up could very well be a system of equations, okay? So what you're going to be doing here is writing a system of equations that models the situation that's given, and then solve it by showing your work. I'll go ahead and set up the first one for you and maybe talk through some of the other ones. Ooh, excuse me. Okay, but I'm just going to set this one up. So you have a coin jar with 117 coins, all nickels or all quarters and nickels. One day you count it and you find that you have $14.45. How many of each coin do you have? So whenever I'm doing these problems, I like to say, well, let's go ahead and define some variables. Let's let Q be quarters, and let N be, guess what? Nickels. All right. So let's go and look at what we have here. So I know that quarters plus nickels equals 117. That's how many total coins I have. All right. And then I look at, well, how much is a quarter worth? Well, a quarter is worth 0.25 Q. How much is a nickel worth? 0.05 N equals the total amount of money I have, 14.45. Okay, just to let you know, this problem would probably be pretty easy to solve with substitution because I have 2 variables up here that have no coefficient. Okay. In the second one, it's only a little tough because we have Ralph and Rita, so you're going to have to get kind of creative with the variables that you pick. You can't really just pick R and R. That doesn't make much sense. It'd be kind of tough. Okay, and it sounds weird. It says that Ralph told Rita, my score is 16, less than twice your score. And Rita replied, my score is 16, less than twice your score. So they're saying the same thing, but it doesn't mean a whole lot as far as their individual scores. Okay, don't get confused with that. Trust me, I've had a lot of people look at me like I'm crazy when I give them this problem, and I've even given that look as well. All right, but go ahead and work it out. It actually works out to an interesting answer. Okay. And then the rest of these are, again, pretty much the same idea. All right, you're looking for 2 different cases. You know, in the first one, it was quarters and nickels, and you had the total number of coins, the total number of coins equation, and then the total dollar amount equation. In this one, you're going to have Ralph and Rita. In this one, you're going to have Bob's electric utility, electric company basically, and Rob. So you have Bob and Rob there. You have Lizzie and Lily there, okay, and Morty and Bertha down below. Okay, they're all going to give you different equations. Solve them using one of the ways you know how to solve system of equations, and you'll be fine. Okay? Let me know if you have any questions. I'm here to help. And good luck on the test that's coming up. Congratulations on term 2.